Can you graph compound inequalities with intersection? Have you ever wondered how to graph compound inequalities that involve an intersection? It can seem tricky at first, but once you break it down, it becomes much easier. Let's take a closer look at how this works. Compound inequalities consist of two separate inequalities connected by the word and or. When we use and, we are looking for values that satisfy both inequalities at the same time. This common solution set is known as the intersection. To graph a compound inequality with an intersection, you can follow a few simple steps. First, solve each inequality separately. This will give you their individual solution sets. Next, graph each inequality on a number line. Once you have both graphs, look for the overlap between them. This overlapping region is where both inequalities are true at the same time, and it represents the intersection. You will want to shade only the area where these two inequalities meet. For example, consider the compound inequality. X is greater than -3 and is less than or equal to 2. When you graph is greater than -3, you will shade all numbers greater than -3. Then, when you graph is less than or equal to 2, you will shade all numbers less than or equal to 2. The intersection of these two graphs is the set of all numbers between -3 and 2. This includes 2 but does not include -3. The overlapping region is the solution to the compound inequality, and you will shade that area on the graph. In algebra, you can also express this intersection as a single inequality. -3 is less than x and is less than or equal to 2. Understanding how to find intersections in compound inequalities helps you see how two conditions can limit the solution set to a smaller range of values. This method of graphing makes it easier to visualize and solve problems that involve multiple constraints. So, when you graph compound inequalities with intersection, remember to graph each inequality first, then highlight where their solution sets overlap. This approach clearly shows all values that satisfy both inequalities at once.